How about now? Thank you so much for having me. It's a true honor and privilege to get to talk to you guys about some of the new research coming out of my very new laboratory here at UCSD. I am affiliated with the Departments of Anthropology, Global Health, the Climate Action Lab, the Data Science Institute here, and we just started the Indigenous Futures Lab. And I kind of want to tell you about some of those new projects where we're kind of thinking about and recombining and merging many different ideas around kind of traditional knowledge, cultural sustainability, and then many different digital tools and kinds of software approaches. So first, I'd like to say that our group, the Indigenous Futures Lab, was recently featured in the MIT Solve Indigenous Communities Fellowship competition, and we did really well, and we won the community prize. So for everyone who voted for our group, thank you so much. This is not possible without your aloha and love and support. The premise for a lot of the projects we were talking about is this kind of colonial root that exists in anthropology and archaeology broadly, and the way that we kind of support a lot of those projects. And here you can see Indiana Jones practicing the what's mine is mine and what's yours is mine philosophy that is kind of consistent throughout the history of anthropology and the study of material culture. This character that Harrison Ford is kind of based off of is named Hiram Bingham III. He actually grew up in Hawaii and was one of the first sort of individuals to really popularize looting, grave robbing, and tomb raiding at some very special places like Machu Picchu. And because of that type of behavior, that's why we see so much of our ancestors' remains and artifacts that are connected to our cultures in museums with a sort of global focus all over the world. So from the British Museum to, the Smithsonian to New York City, filling up cold steel drawers and dusty boxes all over the place. And this includes a lot of indigenous remains which contain DNA. And when you think about it, the anthropology of the past, these ideas around phrenology and studying anthropometry and all of these ideas about kind of human measurement, they're not that different in the way that they prioritize and disenfranchise vulnerable populations, specifically indigenous populations all over the world, right? We have this image from the cover of Miley Arvin's book here called Possessing Polynesia. But when we transition to the now and into the future, there are these new ways in which this disenfranchisement is happening without indigenous communities' consent or any sort of consensus building with a lot of those communities. And that has to do with acquiring human remains from different settings, grinding those human remains up into bone dust, extracting DNA, and then sequencing that DNA. And genome sequencing has become more ubiquitous than ever. I mean, it's easier and cheaper and more accurate. And so this process of building that data and its sort of integration into the big data age of surveillance capitalism apparatus is highly problematic without the consent of communities. And so this is consistent with the past. And this is the same thing that's going on, just using brand new tools. And that brings us to a more existential crisis. Like, are these new tools that are enabling this surge and exponential increase in this new field of ancient DNA? Is it revealing new truths, or are we just falling into the same consistent traps of the past? And I would argue that we're falling into the same consistent traps of the past, and that we're thinking about data, the different forms of data, in many different ways. Like, there's this hierarchical way in the fields of anthropology and data science that we're treating genome sequence data as a more informative and more important form of currency than the other forms of data that might lead you to kind of interpreting or investigating the deep past. Following up on a lot of this stuff, myself and John Hawkes published this piece in Nature looking at this exponential rise in genomes, ancient genomes that have been increased consistently over time. And in fact, more ancient genomes have been sequenced in the first 10 months of 2019 than the entirety of history. This is what we're calling the bone rush. And to make matters more complex, more ancient DNA laboratories have been constructed since 2010 than in the entirety of history. So we're talking about laboratories that have a specific and special workflow for processing ancient remains and digitizing that information. And you can see the majority of them existed in the United States of America, maybe peppered a few here in Europe, and now they're all over the world. And what this means is these laboratories require remains to be processed. And that kind of panders to this anxiety for discovery, because you can't just publish one Neanderthal genome assembly anymore. You got to publish 10. You have to publish X number of papers to make tenure. So this creates this structure in the way that people are trained. So the next generation of students values processing more of this and so on and so forth. Meanwhile, we're talking about a finite resource. We're talking about something that is very precious to a lot of communities. And to make matters worse, it's easier than ever to get your hands on ancient DNA. Look no further than Christie's, Sotheby's, eBay, Etsy, and the new digital playground of Instagram. Instagram has turned into this gigantic illicit market or black market of trade of human remains. And you guys can look into that. It's pretty grim. Knowing that, we've come up with a few strategies and been prioritizing a few strategies to think about this. One of them is a digital ledger system inspired by my uncle's trucking company, trucking weigh-in stations, and many different ways that we create responsibility and accountability and transparency. We can connect ancient remains to negative experiments, meaning if you process ancient remains and the experiment doesn't work, you should be reporting that. When you receive a petrous bone, for example, you should report its weight initially and then after the first experiment. Even if it doesn't work, you should accompany that information with CT scans and all kinds of other metadata, and that metadata should be publicly available through a ledger system. God forbid I say blockchain, but you get the picture. Secure, double-end encrypted. There are all types of opportunities and options to create systems where we have transparency in the amount of indigenous remains that are being processed in museums and laboratories all over the world. They should not be traded around like baseball cards. That includes our data. That includes, rooting a lot of our processes and procedures in the field of data science, indigenous data sovereignty. Another one is computer vision technology, machine learning and deep learning. Many of our audience members may be very familiar with this. I put this amazing picture of this gentleman surfing on this monster wave because we can see this incredibly detailed pixelation here in this wash over here on the top. The reason I did that is because this is an interesting fundamental idea about the way we organize pixels and think about digital information from the point of view of asymmetry and a lot of other different ideas. We all kind of know how this works. We have this process of acquiring images, a second step of analyzing images via training a data set, and then scoring images using different types of processes and procedures, different algorithms that might allow you to create a scoring system based on asymmetry of images or something. So you have a bank of images, you're training your data set, you're scoring, and that gives you insights into which images are kind of more unique or interesting for the thing that you're trying to search for. And we can do that on Instagram. Others, collaborators, Damian Huffer, and is well on his way and working on this. And these are just a bank of human skulls. Forgive me, because I forgot to tell everyone that there are going to be some human remains throughout this talk. So if that freaks you out, I really apologize. you can turn away. But this would be what you would see if you were to look on, for example, if you were to source Instagram for human skulls, for example, and then you can kind of zero in on some of those individuals that are trying to sell these remains online. And this person is even saying, hey, there's some new arrivals, some skulls that exist on Instagram that they're trying to sell. And you can imagine that they use certain types of hashtags and keywords and language that they use in the comment section to negotiate the sales of these. And that could be another sort of entry point for data mining analysis of these horrible people that are desecrating our ancestors. All that is to say, we in Hawaii, or indigenous people broadly, have been indigenous futurists for a long ass time. We were using color newspapers well before anyone in the United States had done that. We had lit up Iolani Palace with electricity well before the White House. Our King Kamehameha recognized the power of gunpowder and cannons and had administered them on va'a, or traditional voyaging canoes. We have always used the most cutting edge technology to support our community's interests, and we will continue to do that. All of that is to say, this is a part of a much larger kind of wave of interest and focus on the decolonial museum movement, and our efforts build on the efforts of many, many incredible activists and people that have been focused on the repatriation efforts. So that brings us to the remainder of this talk, which is about another entry point of using incredible emerging digital tools and genome engineering tools to empower indigenous people, rewrite history, and really think about many of these new and just cutting edge, incredible ideas. A lot of them are rooted in indigenous data sovereignty. So the first part of this talk was about kind of access to our past and provenance of our remains and how they're being processed and digitally desecrated, and how many indigenous communities are not comfortable with that because we're not in control of that data. We're not in control of the process. And so I kind of shared what it would look like if indigenous people were to use blockchain, for example, or machine learning, for example, in the second case and argument. And there are many, many other ways that we're thinking about this. So now we're going to transition to what it looks like when we use genome editing and many other things. So I am from the Big Island of Hawaii, and that's where my family arrived a long time ago from the Marquesas. And we have a saying there, and it's "Ikawama mua kawa mahope," and this means walking backwards into the future. This is how I like to think about the future. And this saying is actually not just a Hawaiian saying. It's quite ubiquitous throughout Polynesia. The Maoris say it; they say it funny. The Tahitians, they say it funny. But we say it this way. And what we mean is we have to be conscious of all of the mistakes we've made in the past and keep our eyes on them as we walk into the future. Don't repeat the same mistakes, right? That was what was so funny about the Trump administration. And so looking at the sort of current situation in human genetics broadly, if we look at and we break down the ethical breakdown of the number of people that have been included in sort of genome-wide association studies over time from 2005 to 2018, you'll see a stark contrast in the types of individuals that were included in the future of predictive and preventative and personalized and precision medicine. It looks like the vast majority of people that were included, according to 3 gigantic meta-analyses, and now this one giant meta-analysis, all were of European ancestry. And that means that the sort of last, the looked over, the left out are not potentially benefiting from a lot of these technologies. There are all kinds of problems that go into this, and I kind of want to share a lot of those issues today about how we include, who we include, what the illusion of inclusion looks like, why it exists, and many of the different ways we can sort of have equal collaboration, participation, and partnership with vulnerable, underrepresented communities. This idea of bias that exists also allows investigators to create what are called just so stories. This is one of my very favorite evolutionary biology papers that was published some time ago in the Royal Proceedings in like 1979. And it was Stephen Jay Gould and Richard Lewontin. And they used this idea of Roger Kipling's just so stories to criticize the field of evolutionary biology and say, look, we're in a phase of rampant adaptionism. You can't just create a narrative around every single piece of data without, causative data if all you have is a correlative relationship. So we've seen this runaway effect happen because more and more genomes that are sequenced are of one population of people, and people are happy to be comfortable in creating these sometimes downright inappropriate and disempowering and disenfranchising stories about indigenous people using our genomes. I had and have an amazing mentor, and he told me once, tell me 2 genes in the genome, buy me a whiskey, and I'll tell you a story. And I think this really embodies that. It's this idea that we can create an evolutionary framework around anything using causative or correlative data. But if you don't have the mechanistic functional information to prove that, then why are you talking about that in the first place? It's just speculation. And there are many different ways that people are doing this. And one of my favorite questions to think about in my lab, and just broadly as a scientist and a biologist and a human being, is how has the environment shaped our genomes? From high elevation in the Himalayas, you can see this beautiful image of this gentleman looking over the Himalayas, and we know that there have been genetic adaptations to high altitude, to Indonesian divers that have involved bigger spleens to hunt underwater. There are many incredible ways that we have adapted to extreme environments. That's natural selection. In that sense, we're no different than Darwin's finches. But which of these narratives is actually true? And I wanted to kind of ask the audience, and even if you can't chime in and say something, do you think that that chronic hypoxia has a higher chance of, shaping our genome, or does acute hypoxia from diving repetitively? And when we look at the narratives that were built around these mutations that were discovered in these populations, one of them actually rings true in terms of a lot of the mechanistic evidence, whereas the other one doesn't have mechanistic evidence to back it up, and that is chronic hypoxia. So all of that is to say we really need to think about the different ways in which we narrativize mutations, and I'm going to dig into that a little bit and show you how we can take these stories to the next level. On top of that, this study in Indonesia with the Baijo, it had a whole bunch of ethical violations that were associated with it. So that is to say, this is a story that wasn't brought to full term in terms of the mechanistic evidence, and it was lacking ethically. You can't do both, folks. You got to have a solid scientific narrative with data that supports it, and it should be culturally sustainable, and the people and the partners that you're working with should be happy about the project. But you can't mess up both. So I wanted to kind of bring up a map or table of all of these different examples that have been discovered in the past. Some of you may have heard of ABO or sickle cell anemia. Nothing has really been more profoundly impactful in shaping our genomes than infectious disease. Currently, we're in the middle of a pandemic, and you can see how that works. We also have this EPAS1 gene and EGLN1 gene. They have been indicated and associated with high elevation adaptation. But for the rest of today's talk, I want to focus on this gene right here, CREBRF. It's very interesting. And it is supposed to be a thrifty gene. That is a gene that predisposes to hypercaloric storage. It was discovered in 2015, maybe a little earlier than that, in Samoa, our brothers and sisters, our Polynesian brothers and sisters. And what's interesting about this gene is that this mutation in this gene looks like it predisposes to obesity, but protects against type 2 diabetes. And that kind of fits into this thrifty gene narrative that was popularized by James Neal in like the 1950s. But if you know anything about metabolic disease, you're probably screaming, wait a minute, you're saying that this potentially has a protective relationship, a protective allele against type 2 diabetes, but it predisposes to obesity. When I hear about those things, I expect a linear correlation. I expect to hear if one goes up, so does the other. So this bucks the trend and is biologically very interesting for that reason. We know a few things about it. We know that the gene is this mutation in it is found in individuals who are obese, who have higher on average BMI. The findings point to this thrifty mutation. But the just so claim, though, this narrative, as we dig into the history of it and the reason why these investigators seem to think that it exists, is that the selective force that maintained this allele in Polynesia is related to the scarcity of calories during the Austronesian diaspora. Now, historically, that's just not accurate, and I want to show you why. But the media loves it, right? The Japan Times calls this the gene that may benefit sumo giants, and how a powerful obesity gene helps Samoans conquer the Pacific. And if you know anything about Polynesian culture and wayfinding, you know that we're the greatest voyagers of all time, and that we utilized all kinds of incredible scientific metadata to find some of the most remote places on planet Earth. And that includes Hawaii here in the north, Aotearoa, and Rapa Nui. And we utilized celestial systems at night. We utilized bird migration patterns and all of these other forms of data, but at no time ever do we have trouble with provisions on the boat. We had all kinds of complex food preservation systems, horticulture. We literally brought kalo or taro to these really remote places, sweet potato, pigs, chicken. Even in Moana, they got this right. So the way you build narrative around that mutation isn't consistent with what actually happened culturally or historically or accurately. However, the rates of obesity are really high in Polynesia, really, really high. Some of the 8 of the top 10 most obese countries in the world as of 2017. I don't think it's gotten any better recently, but this kind of is a way for investigators to connect their argument to this. And you can see that in the data. This is just kind of follow up from that paper. But we don't know that much about this gene, so you could narrativize it any way you want. And even in 2020, this gene is still kind of a mystery in what its effects are on the phenotype. We know where it's located. We know there's evidence for disease association. But when it comes to the mechanism, you can see that it's expressed in virtually all tissues, and that some of these Krebs proteins are associated with metabolism and mitochondrial function. It's even connected to inflammation, which is one of the most profoundly complex biological systems that we know of in terms of health and complex health. My collaborators and investigators followed up and showed that this mutation is exclusively found in Oceanic and Pacifica Moana cultures. And that's very interesting. It was even most recently discovered in Chamorro individuals in Guam. And I think some of the questions we should be thinking about and prioritizing are, how do we properly characterize the effects of population-specific mutations? What do you use to do that? There are many ways to do this. I personally have been focused on using genome editing in a precision form of genome editing called base editing. This is a new tool that uses a catalytically inactive form of Cas9 with a DNA damaging catalyst tethered to it, and you can introduce point mutations in cell lines, stem cells, or any other kind of physiologically relevant cellular model, and you can reverse engineer these population-specific mutations that look like they're under selection. So now we can move from this correlative process of we think this mutation does X, Y, and Z to a position where we can actually speculate and functionally analyze what's going on at the mechanistic level. And that's exactly what we did here. You can see these are sequencing traces from that mutation. And we were able to introduce it into a cell line. And I should note that if you were to go to a company like Synthego and ask them for a knock-in cell line, they'd charge you between $20,000 to $25,000. We did this for, I don't know, $500 probably, much less. And now you can begin to functionally investigate this in physiologically relevant cells. You can actually say, is this a thrifty gene? Can we starve this cell line from insulin and see what happens? What about inflammation? What type of metabolomic readouts do we get? Which networks of genes are interacting when we have this this unique, mutation in this cell line? And it can be easily adapted to gain insight into other mutations in other genes, not just in the case for obesity, right? And we are working with our partners in Aotearoa through the Moko Foundation. There's a CRE-BRF study that's starting to show that professional athletes of Polynesian ancestry within the professional rugby circuit have a higher frequency of this CRE-BRF mutation. So it looks like it's less of a thrifty gene and more of a tall, dark, and handsome gene. So we think that there's a lot going on here in terms of the effects of inflammation and the way that this mutation achieved its high minor allele frequency in Polynesia. Others, including Ripon Mali and S.K. Villerslev, have showed that there are population bottlenecks that occurred as a result, kind of from Cook to Cortez. And this might be one of those mutations that's directly involved in inflammation. For that reason, this is work from their group connecting this idea of sequencing ancient genomes and modern genomes, looking at those time transects and showing that this mutation's under selection because of European contact and colonialism. And so there's a decrease in diversity in this specific HLA gene. So these are some of the cool things you can do with time transects and create more accurate narratives around why certain mutations are at higher frequencies in certain populations. That's our story, and we're sticking to it. But I wanted to get to the last part of this talk and really dive into one of the highly problematic issues with monetizing indigenous variation and creating patent claims around mutations like this CRE-BRF mutation. And that's exactly what happened. These investigators attempted to file a global patent claim, attempting to commercialize the exclusive use of this physiological response of this allele. And to me, that's horrible. That's not a type of scientific community I want to exist in. And you're probably thinking to yourself, well, wait, Keolu, what about the Mary Claire King versus Myriad Genomics case? What happened there? Isn't that supposed to be protective policy against this sort of thing happening? And what's happening now is that geographically sequestered populations are yielding mutations that can give insight into the development and fast tracking of research and development of these different types of blockbuster drugs. And we're seeing this happen all over the place. And I'll show you a few examples of this. But this might be an avenue for the development of something that could help with the protection against type 2 diabetes, even though this mutation was identified in and extracted from a Polynesian population. There's no way to protect against the commercialization of it because the community wasn't involved in any of the creation of the intellectual property. So that brings us to another kind of deep existential question that I'd like to leave everyone with, which is, should all genomic data be open to the public? And if so, why? We are huge proponents of indigenous data sovereignty. This isn't a moment. This is a movement that's going on within data science in so many different directions. And our chief focus in connecting this to the sort of age of surveillance capitalism, data and big data apparatus is through digital sequence information derived from genomes. So that could be bacteria or animals, creatures, plants, and certainly humans. So We think about questions around how we recognize indigenous rights and interests in, the generation of this raw data, especially within open data environments. We think about how to share this information and how to collaborate around ethical access and use in ways that are consistent with community protocols, and how to negotiate equitable outcomes from the use of digital sequence information, including commercialization. Other companies aren't really thinking about this at all. They're just making hay when the sun shines. So Regeneron, for example, even is putting out blog posts telling you, we're stacking the deck for genetic discovery. We're using and utilizing these geographically sequestered or isolated populations to identify these low-hanging fruits in the forms of these mutations. And we're going to create the next generation of cholesterol drugs, for example. And there's precedent for this because the creation of pesky 9 inhibitors, the kind of really interesting mutations that were discovered in this gene were discovered in African and African-American populations. This is a new blockbuster drug. Regeneron is working on a whole new class of another cholesterol drug. And this idea of fast tracking and expediting the development of drugs is going on in a number of different directions. There's also the creation of the first $300,000 drug from Vertex. This is a drug where they used and utilized cystic fibrosis sequence variation, and they refined the development of this drug from patients that had cystic fibrosis, feel me, and then they sold it back to these patients for $300,000 a year. Now, to me, that's not the type of healthcare system, insurance system, or scientific environment I want to live in. This is something that we should be, talking about at the very least. But I mean, we can't allow the development of more drugs like this to happen. This is not good for medicine and science and the ways that capitalism has this tight grip on the development of pharmaceutical drugs and therapy in this country. So I'll leave you with this and thinking about the NIH's All of Us program, which is a large-scale government initiative to sequence 1 million people's genomes using your hard-earned tax-paying dollars. And they want to oversample for 50% of that data set being from Black, Indigenous, Latino, underrepresented minority populations. And one of the problems with that is that is going to lead to the development and identification of mutations that could be used to create new forms of drugs. So something we're advocating for is benefit sharing and thinking about the different ways in which we utilize benefit sharing to equally distribute the potential royalties, intellectual property, that is associated with the development of a drug that might be developed from a population. And there's precedent for this as well. One amazing example of this is rooibos tea profits that were derived from the San and Khoi communities. And they receive large shares of the proceeds from this. And this is in step with the UN's Biodiversity Convention, or what's called the Nagoya Protocol. Another great example of this is in diamond mining in Botswana, where a large portion of those proceeds go back to various programs that have been transformative of the whole economy in Botswana. This includes cultural revitalization programs. It includes healthcare and education program. It's been wildly successful there. And I talked about this most recently in the New England Journal of Medicine, connecting this idea to equitable approaches to benefit sharing, including with respect to this NIH's All of Us program and the current research and development model, and how these resources could be more equally distributed if these processes and procedures were rooted in Indigenous data sovereignty, and how this could lead to equitable benefit sharing that would really greatly impact Indigenous communities all over the world. We're thinking about this from a top-down approach, and we're thinking about this from the bottom-up or grassroots approach as well. And we'll see what happens in the future working with our island brothers and sisters all over the place, including diaspora communities that exist in Southern California, Nevada, Utah, all over the place where our people have voyaged. And I will leave it at that. Thank you.
Keolu, you've got, we still have about 12 minutes left in the hour. So if you wanted to talk a little bit about the Indigenous Futures work, you still have a couple of minutes.
Yeah, sure. Let me dial that in. And
also, folks, if you have questions, type them into the question section. We'll get to those in a couple of minutes.
Okay. Well, then I'll kind of, I tried to speed through some stuff, but I will focus on a few ideas. That is not to say that there aren't, like, the picture I painted is part of it is pretty grim. So I wanted to focus on some of the positive stuff too. In 1998, there was a truly successful collaboration between the University of Otago and a family, a Maori family, that came to that university, and they said, we have really high rates of gastric cancer. We have reason to believe that it's inherited. What can we do? And they moved forward with this really elegant, what in genetics is called a pedigree-based study. And they were able to identify a new gene that could be used to predict and prevent gastric cancer in all populations of people. This has been tremendously successful in thinking about ways to perform and activate treatment around gastric cancer in the Maori population. And they also did something that was unique at the time, and they included 4 of the individuals from the community. I believe some of them were like nurses and orderlies at the clinic, that are part of this family, the MacLeod family. And they're Scottish Maori. And it's just really interesting because this is such a success story. It's like from top to bottom. The community's happy about it. It has direct impact in the health and health disparity in Polynesia. And in terms of creating currency for those individuals, they included them in the author list in Nature. And this was in 1998. So that begs the question, like, how hard is it to do this? It's not that hard. It's not that hard to include your community partners in the process and just create and co-develop better projects that are going on. Man, me and a lot of my buddies have been kind of putting out the playbook for this. This is a paper from Katrina Claw and Nanaba, Renee. They're all Dene Wahines. And my friend Matt Anderson, he's an amazing human being as well. And it's just thinking about the ways in which we root these projects in sovereignty and how that just really affects everything else in a positive way. And we had our Sing Indigenous Genomics Conference in Waikato, Aotearoa. And this was our first Indigenous Genomics Conference with all Indigenous speakers. And here you can see our speaking winners and poster winners here with one of the lovely editors from Nature Genetics. And all of that is to say, like, we're doing our thing, we're doing our thing. I've started the Indigenous Futures Lab. Here's my co-director for the program, Hinano Murphy. She's currently in Moorea, French Polynesia, and we're thinking about a number of ways to enhance ethical genomic research with Indigenous communities. We have a number of projects that are going on there. And the Indigenous Futures Lab broadly, we have so many different projects that we're working on with our local communities, the Kumeyaay Nation. We're working very closely with a lot of our diaspora communities here. And these projects just extend in a number of different directions. And they're all kind of rooted in this idea of local complexity. Like, how do you provide solutions for things that are based on local complexity? Whether it's health or repatriating the past or counter technologies to prevent against access to, illegitimate access to our ancient ancestors' remains. And a lot of it is inspired by our relationship to our indigenous brothers and sisters at the border as well. That creates a lot of tension and problems. So we're thinking about things there. And if anyone's interested in hearing more about that, I'm happy to speak to that. And this is just more on working with Hinano there in at the Gump Research Station. And I guess I'll just leave you guys with a song from a recent. I don't really like going to church that much, but it is a way to connect with the communities. And here's a beautiful song from Tahiti.
All right, that was really wonderful, Keolu. We have some questions.
Sure, thank you.
So, I will read them to you from the chat, unless you want. You can go to the questions thing. But the first one's from Maxim Senkov, who is at the University of Dundee, so in Scotland. By sequencing underrepresented populations to diversify the database of human population variant data, should we continue using the current human genome reference in research, or do you think we need to create more genome references?
Brilliant question. Brilliant question. In fact, one of the things we're really, really interested in, and one of the, I think, thought leaders in genomics who's been thinking about this is Evan Eichler's group. And they have been really, it's like you can create more of the same, which is like low quality genomes and lots of them, or you can create really high quality long read references where you have like the resolution of some of the most complex regions of the genome, repetitive regions, copy number variants, inversions, stuff like this. And I think that's the move. I think that allows you to impute other forms of variation from the sort of lower quality data sets as well. So I tend to agree with our friend from Scotland. Like that's the direction that everything should go. In terms of reducing bias that exists in every study, we know it's going to be inborn because of the quality, not just the quality of the genome reference, but the fact that it's of one ethnicity. And so we're using that to kind of chart every other form of variation. So if you want to talk about that, my friend from Dundee, like I'd love to come there. I love Scott.
It's a great place. I'm gonna ask a sort of follow-up question to that.
Sure.
So one of the things I think that's been so interesting about your work recently and other Indigenous scholars is this idea of moving from data sharing to benefit sharing.
Yeah.
I was curious your take on, there was a recent publication of a couple hundred genome sequences from sub-Saharan Africa, which really showed that the vast majority of variation in the human genome is in Africa. It's not too surprising in a way, but it's a little tricky to figure out who the benefit should be shared with. That's an enormous population of extremely diverse cultures and geographies and the like. So how, if you want to design benefit sharing plans, how do you figure out shared with whom, right? Or for geographically isolated populations, it's a little easier, but for a place like Africa, it's a much more complicated question.
Yeah, I agree. I think that's an absolutely outstanding question that we probably don't have all the answers for yet. I do appreciate our focus on local complexity in this way, because it's like there's so much cultural variation in so many different places in Africa. Like if we just take the Gold Coast, for example, there's so many different communities of people. So let's say you do derive a drug and you want to redistribute those royalties into communities or programs. There's kind of two models that we've been toying with and thinking about. Obviously, like we're early in the innovation of this, but I think that one of them is like a stakeholder model where if you participate, you get a cut. you're like a stockholder. So you'll get, some access to this through some digital ledger system or something. The other one is a community trust model, which, as you know, is way more vulnerable to corruption, right? Way more vulnerable to cronyism. And that's highly problematic as well. You could put like strict rules about how the money is used. So you could say it has to go into like an education program, a cultural revitalization program, and an agriculture program or something like this. But even then, the way the money and the finances kind of trickle down could be problematic. But I think what we've seen with some of the like comparisons in Botswana with the way that diamond mining has just been, which is the most extractive probably process on planet Earth. I can't think of anything that's pretty bad. But the way that it's transformed their economy since the 80s, I would like to see like more of an analysis on what has been effective. One thing I really want to do with like maybe like the World Economic Forum, if you're listening, is bring together all of these world leaders from different avenues within benefit sharing. So agriculture, mining, anything around data or data-driven stuff. Now we have companies that are kind of taking up these ideas within the biotech and big pharma world and say, okay, what has been effective? What has been a failure? What are the limitations? What are their expectations? And then how can we kind of plan this out for the future? And educating our all of these different communities that this is an option and an opportunity to redistribute wealth and create circular economic ecosystems rather than just like more of the same, which is extractive capitalism, which clearly is not working.
Yeah, big task. I don't think we have any World Economic Forum folks in the audience, but we do have, I've seen some very senior leaders in bioinformatics, so you do have a good audience. Mm-hmm. It is the top of the hour, but I'm going to take one last question. This one's from Satyesh Yazdani at the MSc Structural Genomics Consortium. And the question is, how would you describe the approach of personal genomics companies like 23andMe when it comes to conducting ethical genomics research? I figured that'd be a good place for you to wind up.
Oh, man. Well, I would say that I think like at the top of it, remember, that's a Google company. I highly recommend reading Shoshana Zuboff's The Age of Surveillance Capitalism. That like changed the way I think about so much of the world. I mean, I already had these inklings, but you have to remember, if you're paying someone $150 to tell you where you're from, and return you medically actionable results that aren't actually medically actionable, and then they bank that data and that information, and they sell access to it to GSK for $300 million, and they have already committed to developing a new anti-inflammatory autoimmune disorder drug that's coming out with a Spanish partner this year. And you see that happen, you have to start to ask questions about how your personal information has been used to create a potential blockbuster drug, and you're not going to get a single penny. Now, I want to take it a step further. Let's talk about Ancestry.com, which just got sold for $4.7 billion to the Blackstone Group. How do you think they're going to integrate and utilize that information? So I think, the proof is in the pudding, as they say. I don't think it really needs much more explanation other than this information is already being integrated into those forms of the digital economy, and we would be foolish to pay someone $150 to have them sell your information. I don't know, it seems silly to me, but